And over the next 20 minutes, I'll be giving you an introduction about how to do real-time analytics using the various services in Azure, right? So to give you a very quick understanding of like why do we need real-time analytics, you get data from so many different sources, and a lot of the insights that you gain from this real-time data it has a very short shelf life. So if you're able to make sense of this data in that very short period of time and take actions based on that, that becomes a very powerful construct. So how do you do that? So think about cases like credit card fraud detection, right? So if you're a bank and if you have millions of transactions that you need to analyze and use complex machine learning models to detect whether it's a fraudulent transaction or not, you need to do that within a matter of few seconds, or the damage is likely done in most cases. So when you think about the end-to-end pipeline of how real-time analytics is done on Azure, so this is kind of like a canonical representation. So you have all the different data sources on the left, where you have data coming from IoT devices or your applications or your logs. And all this is real-time data, right? So what is the first step? You need to ingest it into Azure. So how do you do that? So the first step would be your application data would go to Event Hubs, and your IoT data would go to IoT Hubs. So let's look at Event Hubs, right? So you might be familiar with Kafka. So if you have an existing Kafka cluster which you're writing to, which is on-prem, and you want to migrate to the cloud, you can just change the connection string of your apps to point it to Event Hubs. So you don't have to make any changes to your code. Your applications will still think that it's actually writing to Kafka, but internally it's writing to an Event Hub. So when your data lands in Event Hub, what do you do next? You need to get insights based on that, right? So that's where Stream Analytics comes into the picture. It is the engine that is up and running 24/7, continuously looking for the data that is coming in and processing and producing results. So historically, when you think about analytics, you have your database or a data warehouse, and you run some queries on top of that, and you build reports. This kind of flips the whole thing around, where you have a query that is up and running 24/7 all the time. And so the data is going against the query instead of the query running on top of the data. So once you have your analytics logic implemented in SQL in Stream Analytics, the output can be sent to any of the data stores in Azure. So it could be a data lake store, Event Hubs, database, data warehouse. You can even create a Power BI dashboard, or you can even trigger an Azure function to do some custom logic and maybe send alerts to the right people in your organization. And we also have integration with Azure Ml. So if you use any of the open source machine learning frameworks to build your ML models, you can host it as a web service and use that in the context of Stream Analytics to do real-time scoring. To give some background, we are available in like 27 regions worldwide across Edge and Stack as well. So thousands of customers are using Stream Analytics. And why did they use it? It's mainly due to three things. One, it's so easy to use. Like connecting to the input Event Hubs, writing to like a database or a data warehouse, all that is just a matter of few clicks. And to get an end-to-end pipeline up and running, you just need to know SQL. No need to do complex code or complex custom code. As long as you know SQL, you'll be able to build a real-time analytics pipeline in less than 15 minutes. And I'm not even kidding. So in terms of cost, it starts at around $80 per month, which itself gives you quite a lot of compute power to do sophisticated analytics. All this, with which we guarantee 3 nines of SLAs. So think about a real-time pipeline, right? You want it to be up and running 24/7, continuously processing the data all the time. And if we are not able to guarantee that uptime, we will financially back that for you. So let's look at all this in action right now. So here, so this is an Azure Event Hub. So this has been pre-configured to receive real-time taxi data, which is sent from a simulator to this Event Hub. So here you can see in the middle that this Event Hub is actually receiving a lot of incoming messages. But how do I actually make sense of that and start getting insights from it? So here I can see a type called process data. So let's click on that. And so here I am going to explore the option of using stream analytics to look at what that data looks like. OK, so here you can see that you have your input, which is the event hub, where the data is being sent to, or you're receiving that real-time information. And here, immediately, when you launch this, you can see that these are all the different fields in the incoming payload that you have. So I can see that there is a rate code, what is the number of passengers in each ride, how long did it take, where did they get picked up, where did they get dropped off, and things like that. So I can simply write a very simple SQL query. It could be like select rate code and passenger count from taxi ride 5, and I'm going to hit test. So when I actually hit test right now, it is executing this simple SQL query against the real-time data that is being received by the Event Hub. And once the computation is completed, you'll see the results based on the real input that the Event Hub is receiving. So you can actually take this to the next level and have more sophisticated analytics. So let me just, I have this pre-populated query, which I'm going to be copying and pasting here. And taxi ride 5. And so when I actually get a query like this, let me just make a lot of things easier. All right, so I have a fairly simple query right now. And if I test this query, it's going to count the number of pickups that are happening. And it will show that to me right now. So here you can see that I am reading the information coming in real time. And I'm doing a bunch of very simple selects. I'm looking at the latitude, longitude, a couple of other fields. And I'm using the inbuilt geospatial capabilities that Stream Analytics offers to do things like I'm creating a point, and I'm calculating the distance between the pickup latitude and longitude, and looking at how far away the pickup has happened compared to this point. So this is the lat-long coordinates for the Microsoft store in Manhattan. And so the real-time data, unfortunately, in the last few seconds, there has not been a pickup. So that's the reason why you're seeing 0 results. But once you have this, once you have a query that is actually producing results that you want, you can click on Deploy Query, give a name, say sample ASA job, and I'm going to pick a region, and I'm going to hit Create. And so once you do this, you're going to have a job that is running. So this is a Stream Analytics job that is running in the cloud, looking at the same taxi information that is happening in real time, and producing results. So here you can see I have some basic statistics that this job is reading so many. The number of input events in the bottom is around 108 per second, and the number of outputs being produced is 84. So let's go see what this dashboard really looks like now. So the output of this query is being sent to a Power BI dataset with which I have created this visualization. So if I expand this, you can see that the first top part of the tile shows the number of pickups that are happening per region within different areas in Manhattan. So I'm able to see the number of pickups in Financial District, Harlem, Midtown. All this gets automatically updated based on the new data that keeps coming in. So if you're a taxi vendor, having a visualization like this can help you figure out where you need to route based on demand and things like that. Another interesting tile that we have here in the bottom is the number of pickups and the average cost per ride in each of those regions. So how do we predict what is the ride cost going to be for each region? So that's where machine learning comes into the picture. So you can have a model that is trained to take in a couple of input parameters based on the ride information. Things like what time of day is the ride happening? Which day of the week is it happening at? What is the trip distance? How many passengers are there? And using all these input parameters, your model can predict what is going to be the approximate fare. So here we can see that the price or the average price of the rides are actually higher in these couple of regions, and the number of rides that are actually happening there are fairly low. So you might want to kind of send more taxi rides if you're the vendor there in those kind of cases. And we're also doing some other basic calculations like the number of pickups near the Microsoft Store and also the average trip time. So in terms of exploring the data set, so if we go back to the Event Hub, right? So I want to show you another cool aspect here. So you click on Process Data and hit Explore. So when your data is actually coming in, you can actually write and test queries multiple times here without any limits. And it's not just restricted to JSON. So JSON, CSV, and Avro, they're all, maybe there is some issue with the simulator that's not sending events right now. But so you can, it doesn't necessarily have to be restricted to JSON. It can be CSV data, Avro, whatever format you name it, and Stream Analytics will work with that. And some of the most advanced sort of like capabilities that we provide out of the box is metrics. So if you have a real-time analytics pipeline running in your enterprise, you want to make sure it is up and running all the time and processing data. So you're not going to be constantly sitting in front of the web page and making sure it's running, right? So that's why we provide a lot of metrics out of the box. If the internet wants to work, come on. So things like the number of input events, the number of errors that your job is producing, the utilization of your job. So all these, you can set alerts on. So if your utilization goes above a threshold, say 90%, then you can send an alert to the data engineer on your team so that they can come and take some corrective actions based on that. I wish the internet was slightly better today. Oh, yes. So yeah, these are the different metrics that we provide out of the box. So things like utilization, runtime errors, how many inputs are backlogged, and things like that. All these are very sophisticated metrics that keep getting updated in real time, with which you can actually rest assured that your pipeline is continuously up and running and producing data all the time. So if let me just take a couple of minutes to explain how easily you can write the query that is powering this entire dashboard, right? So in the first step, so before I start, how many of you have some basic knowledge of SQL in this group? All right, perfect. So all of you can really build this end-to-end pipeline in 15 minutes. I am not even kidding. You guys should actually go try this out yourself. So here, this is taxi ride. So I have 3 inputs. So if this is the Event Hub, and these two are some region reference data is a static data set, which has the region definitions for Midtown and different parts of Manhattan, right? So I'm getting the real-time information from the taxi ride information, and I'm picking up the right fields. And here, in this query, what I'm doing is I am looking to join the real-time streaming data with the region reference data set, which has the polygon definitions. And I'm creating a point based on every pickup latitude and longitude, and using the inbuilt capabilities such as ST-within to check whether this pickup has happened inside any of the geometries that I have defined. So if it has, then it will return 1, in which case I'm going to be grouping it by that region name. And so that is how you will see the region names such as this and the counts varying over a period of time. So you might have a question. So this query has to execute over a period of time, say 5 seconds or 30 seconds, and how do we do that? So that is where the concept of windowing comes into the picture. So here we have a hopping window with these 3 parameters. So this basically means that for every 5 seconds, the job is going to be looking at the last 60 seconds worth of data and doing the executing this query on top of that data. So this can be configured. You can keep it in the order of minutes, hours, up to 7 days. And the more data you have, your query is going to be more complex, and all this data is kept in memory to do the processing, so you will need a very powerful stream analytics job to do that. So coming back to the scaling aspect of things, this job right now is running at 3 streaming units. So one streaming unit is basically some amount of compute and memory that is allocated for your job. So when you start with stream analytics, you don't need to worry about managing clusters, maintaining clusters, nothing like that. You just need to have an input source, have a few clicks, start streaming the data, write your SQL query, it'll start producing results, connect it to a Power BI dashboard with few clicks, and you have it up and running. So there is no clusters to manage, nothing to maintain. You just have to focus on writing your simple SQL query, and everything is taken care of for you at that time. So one streaming unit starts at $80 per month, and you can scale up to 192 streaming units to tackle terabytes of data per day. So this is a very quick overview of the whole real-time engine in action. And if you have any questions now, I'll be more than happy to take that.
Please forgive my ignorance.
Sure.
Well, I didn't mean to make it public. Anyways, so the question is, first of all, can I have multiple streams effectively joined in the output in the manner how I can join multiple tables in a database?
So you want to join it in the output or the input?
Well, basically, say I have 3 streams.
Yeah. Incoming streams.
Incoming streams.
Yeah.
And I want to create a data structure at the output that would be effectively a join.
Yeah. Of all the 3 streams.
Right.
Yeah, absolutely, you can do that.
Right. So for as long as my streams have
some
field-like structure.
Exactly.
Another question. If, for example, I have streams that don't have, like it's plain text or something, is it possible for me to insert some sort of normalizer, or I don't know how you call it, a plugin that would be at the very front edge and would actually structure my input?
I see. So you're talking something about how do you pre-process the data before doing it in
precisely.
stream analytics. So we actually have another option called user-defined functions. So if you have, you can create a JavaScript function, right? So here in this example, I have a create array function, which basically looks for a bunch of fields, and I'm trying to like package it up as an array and then create the output.
So I can do some textual analysis and splitting on fields and basically actively creating structure out of unstructured input.
Absolutely. So you have the option of doing that using JavaScript or C#. Okay. And so you can take all the input fields that you have, create whatever structure that you want, and then do further processing on top of that.
All right. So another question. I'm sorry.
Yeah, absolutely.
Maybe I'm hijacking this.
No, go for it.
So can I, say, point my stream to 2 different queries?
Point your stream to 2
Basically,
different...
one query would filter certain patterns into a separate further processing. Okay. And another query would be concerned with different patterns.
Yeah, so you can have multiple queries executing on the same data, looking for different fields, and each of them writing to different outputs. You can do that all within the same job. So even if you look at the same job that I'm showing you here right now, I actually have multiple queries doing different things.
Oh, I see.
So here I'm just doing a bunch of selects. So this is producing one set of results. And this is producing another set of results.
Excellent.
And this is producing another set of results. All this with the same job, working on the same input streams. You can get as creative as you want with that.
And kind of obvious next question.
Yeah.
Can I, in fact, chain the queries?
So when you say chain, like the output of one...
Basically turning it on its side.
So yes, absolutely. So you can have something like a with statement here. So what we do is this is like the step number 1. So this is like a step. You're basically selecting a bunch of fields here, and I'm using trip data as in the from statement. So this is trip data, right? So I'm using trip data in the next part here. And so same thing goes for here as well. So I am using the output of one query in another query in the same job as well.
Okay.
Right, great, thank you. Yes, yeah.
Following to your question, where can we see the other languages that we can use, like C# and JavaScript?
Yeah, so right now on the portal, if you see that, it will be part of the portal. So here you can actually, yeah, so here under functions, you'll see add JavaScript functions or C#, but right now C# functions is supported only in Visual Studio. So you'll have to use Visual Studio tools to author your UDF because that provides a lot better experience. And JavaScript can be written using the portal itself, but if you want to use C#, you'll have to use Visual Studio.
My question was around Power BI is explicitly defined as an output. Are there other output endpoints that I can use?
Absolutely. So there are so many multiple different outputs that you can actually use directly out of the box. So here, wish this was loading. So there are multiple outputs like data store, data lakes, databases, data warehouse. I wish the internet was slightly faster, but yeah, it's the same thing. So you click on outputs, similar to here, and you click on add, and a drop-down would appear with all the 10 or 12 different output adapters that we support. So you can choose a database and then configure your database details, and then provide the table name, and then Stream Analytics will start writing to that. All right, cool. Yeah, absolutely. So if you guys have any more questions, like I think we're getting running out of time, so we can meet at the
slide with the links to the materials.
yeah, sure. So we can. So a lot of the content that is actually there is present on our. So you can go to aka.ms/Azure streaming, if I remember correctly. No. OK, so it's not there. I think if you search for Stream Analytics, it should show up in docs. Yeah.
I think it's a pretty quick question.
Sure.
How do you recommend scoping hubs?
Uh,
I saw